Okay, so this is the transformation formula for a quadratic equation. It has a and h and k in it. And with any of these, with whatever equation you have, you'll describe the transformations, and that is the math vocabulary that explains how the equation you're graphing compares to y equals x squared. And if you write y equals x squared as this transformation formula, then a is 1 and h and k are both 0. We call this a vertex form equation for quadratics because the vertex is hk. And I put scissors over to the side. If you want to cut these on the lines and make little doors, then underneath on the inside under the door is what happens. This one is what happens when you change the number from 1 to a different number for A. And that next is what if you put a number other than 0 for H, and what happens when K is not 0, it's something else. And then lastly, what if the A is negative? There's a negative sign in front. So these are all the changes we'll talk about, and those are transformations. Here, this is the inside of your notes, and I have a couple of examples to go with each variable that we're changing. A determines the shape of your graph. The original shape has A equal to 1. So if A is 1, then there's nothing to talk about. That's not a transformation. That's the original shape. So, and I don't have any vocabulary to describe I didn't do anything. So you can just leave it out, or you can say no change or whatever. Anytime the A value, the number, that's why it's an absolute value bracket. So regardless of sign, the number for A, if it's bigger than 1, then you have a vertical stretch. So your graph is going to be taller and skinnier. It'll stretch up and down. The changes that we make to shape and direction in this class will only be vertical changes. It's also possible to have a horizontal stretch and you stretch it sideways, but we're not going to address that. We're just going to do vertical stretch. The opposite of a stretch is a compression. That happens when the A number is between 0 and 1. So here I have a vertical compression. Instead of getting taller and skinnier, it gets squashed like it got stepped on. This one is like wide and flat. Okay. So these are opposite of each other. And again, if A is 1, then it's the original regular shape. A is going to be used for well, I'm going to introduce a way of graphing today in a few minutes. That is the step pattern. It'll be a multiplier. It's kind of like slope. It'll affect if your slope is 5, that's a really steep slope. It's very vertical. If your A is 5, that's a very skinny, tall graph. If your slope is 1/10, that's just almost flat. That's very compressed. So A is similar to slope. It's not slope exactly because it's not a line. We're not going to be graphing a line, we'll graph a curve. So the slope will change all along the whole curve. But you can think of it kind of like how slope works. Here are my examples. I have one where A is 3. So since 3 is bigger than 1, I would say A is 3. A is the number that's multiplied by the x squared. And I have a vertical stretch. And you write by 3. Whenever you describe one of these changes, you also say how much, how much it's different. The next example, A is 3/4. That's between 0 and 1. So I would have a vertical compression by 3/4. This next example, I have y equals 5/2x squared. Would this be a stretch or a compression? It's stretch. 5/2 is a fraction. I put this on here because many times people try to remember by if it's a fraction, it's compression, and if it's a whole number or an integer, then it's a stretch, and that's not necessarily true. 5/2 is 2.5. So if you're given 5/2 for an A value, that's a stretch. It's a vertical stretch by 5/2 when A is 5/2. You could also write 2.5. The next variable we'll talk about is h. H is in the group with the x. We're looking at the notes that I gave out Tuesday. So I'm hoping you have those. If you don't, I know there are extras. So here, H is always in the group with the x. If the middle of your equation says x minus number, then H is a positive number. And your graph will shift to the right. If your middle of your equation says x plus a number, the reason it would be written by like this is that it's actually x minus a number, but it's minus a negative, and that's awkward. We don't usually write things like that, but it's equivalent and you can write it like this. Whenever you have x plus h, then that h value is negative. And your graph will shift or translate to the left. H is the x part of the vertex. Our vertex is HK. And just keep it in mind that the sign for H is opposite of what you see when you read the equation. So when you read in the equation like this, x plus 3 squared, then the h sign is negative. And when you see x minus 2 squared, then the sign of the h is positive. The sign is always opposite of what you see when you read the equation. This bottom one should say x minus h. Nope, x equals h, sorry. X equals h, that equation is the equation for the axis of symmetry. And that's because the axis of symmetry will be a vertical line, and it goes through the vertex. And the x part of this vertex is h. So x equals h is the equation for the axis of symmetry. Let's describe these equations I just showed. My transformation for this equation is that since h is -3, my graph will shift left 3. For this other example, when I have x minus 2 squared, h is equal to +2. So for this graph, my equation will shift right 2. The next equation, or the next variable to describe, is k. And k is added on or subtracted from the very end of the equation. If you have plus number at the end of your equation, then k is a positive number, and your graph will shift up. And if at the end you have minus number, then k is negative, and your graph will shift down. K is the y part of the vertex. So here, yeah, I got HK is my vertex. K has an effect on the range because K will either be the highest or the lowest point on your graph. It'll either be the maximum or the minimum value. So for these two examples, I have x squared, there's nothing with the x, so this is not h, this is k at the end. Here I have k is a +6, and so my graph will shift up 6. And then for this example, x squared minus 4, k is equal to -4. So my graph will shift. All right, shift and translate mean the same thing. I just want to keep that in your working vocabulary. Down 4 units. The last thing to talk about is if there's a negative in front of the equation. And we consider that to be part of A. There's a negative in front, then I just need this to move. Okay. If there's a negative in front, then your graph is reflected over the x-axis. You could also say it's a vertical reflection, just so it's clear that it's an up and down reflection, not a sideways reflection. You could say vertical reflection, that means the same thing. This is separate from the number for A. So we talked about A, and that is a shape thing. This is completely different, has nothing to do with the number. This is if it's positive or negative only. So A, that first number that's multiplied in front, affects the shape, and it also affects the direction. And the direction is because it's positive or negative. That'll be the direction it opens. It opens up if it's positive. It opens down if it's negative. So since this affects which way your parabola opens, this also affects the range. Whenever you have a positive number, then your range will be, well, it'll go like this. It'll open up. And so your range will be from K, the lowest, to infinity. Whenever A is a negative number, your graph is upside down, and we do lowest to highest for range. So your range will be negative infinity up to K, and K will be the highest. And there are some examples here for this. I have y equals negative x squared. For this problem, A is -1. So it's the original shape because the number is 1, but it's negative. That makes it upside down. This is reflected over x-axis. This next example, y is x squared. It's 1x squared. A is 1. And when A is 1, there's no transformation. There's no change. This is the original shape. So please don't say it's reflected if A is positive. I just don't even have a description for that. It's just a normal graph. And this last one, A is -2x squared. I do have some students that make an error and say that this is reflected by 2. It can't be reflected by 2. That's not how that works. What I have is A does 2 changes here. One of the changes is because it's negative. That gives me a vertical reflection. The other change is because A is not 1, A is 2. So that changes the shape. I have a vertical stretch by 2. When I give you an equation and I ask you for the transformations, what I'm looking for is these vocabulary words that describe what you've done or what the equation does to the graph to change it from the original at y equals x squared. So I could say an equation has how about this? This equation has a vertical reflection and a vertical compression by half. and it's also shifted up 1. Those are transformations. So whatever combination of changes compared to y equals x squared, the original graph, what you do to this to change it to be this, that's the transformations. Until you get comfortable with which ways these things change the graph and which way it moves and where the vertex is and that sort of thing, I recommend very highly that you graph y equals x squared, and you also graph the one you're trying to describe, and then explain what you do to make this one look this way.